Hey guys, so I'm going to go over these review problems with you. This one is a trinomial, factors into the product of two binomials. You know the signs have to be the same because the product has to be positive. You know they both have to be negative because the sum has to be negative, and your answers are 7 and 3. So x equals 3 and x equals 7. That's all you do. For this one, it's a binomial, but there's a GCF. So you factor out an x, you're left with 4x minus 1 equals 0, x equals 0, x equals 1/4. Here we're going to do a trial and error trinomial. I have no idea what the answer is, I'm just winging this. I'm guessing this comes from 2x and 2x, and I'm guessing 5 comes from 5 and 1. Problem is that doesn't work because 4 times 5 or 2 times 5 is 10 and 1 times 2 is 2, and 10 and 2 is never going to get me 19. So that doesn't work. Let's try 4 and 1. That gets me 20 and 1, and I need the 20 to be positive and the 1 to be negative, and that equals 0. When I solve this equation, I get 1/4. And when I solve this equation, I get negative 5. Okay. So that's it for solving by factoring. You factor, you set your two factors equal to 0, you solve each equation. Okie dokie. Let's try what's next. Solve by graphing. That's when you want to do it on the graphing calculator. I don't know how to get a picture of my graphing calculator on this screen, so I'm just going to do it and talk you through it. I go into y equals. I don't know about you, my plots are still on because the last thing I did was a scatter plot. So I need to do that, and then I'm going to clear my y1, and I'm going to go math over to num abs x plus 5 in y1, and then in y2 I'm going to do math num abs x minus 3, and I'm going to graph them. My window is also still messed up from the scatter plot, so I'm going to go zoom 6 to get a 10 by 10 window. Now I can see that these two graphs cross in one place, so I'm going to go second trace to get the word calc. Intersect is choice 5, and I'm going to push enter 3 times. That gives me an intersection of -1. X equals -1. Now, y equals 4, but think about what that means. All that means is that when I plug in -1 for x, -1 plus 5 is 4, and the absolute value of 4 is 4. -1 minus 3 is -4, and the absolute value of that is 4. So the y value when you plug in the answer is the 4. That's where that comes from. For number 5, I'm going to add 2 radical x plus 3 to both sides, so I have x plus 2 equals 2 radical x plus 3. You don't have to do that. You could, since it equals 0, you could calculate the zeros of the function by using second calc 0. I like it to not be on the axis. I like to be able to see what I'm doing. So I'm going to type this in. The square root button is above the x squared. You have to push second x squared to get the square root button. And then it appears on my graph that they cross in one place. So I'm going to go second calc intersect, enter, enter, enter. And the answer is 2.83 where they cross. X equals 2.83. Sorry, Marty, here's my equal sign. They never show up good. 2.83 is where they cross. Okay, to solve by taking the square roots, we have to get one square on one side and the other on the other side. We can't have it equal 0 to take square roots. So I'm going to add 96 to both sides, and then I'm going to divide by 3. So x squared equals 32. Take the square root of both sides, and x equals plus or minus the square root of 32, which is simplifies into 16, so 4 root 2. For this one, I want to divide by 4 on both sides, so I have x plus 1 squared equals 18 over 4. Take the square root, so x plus 1 equals plus or minus the square root of 18 over the square root of 4, but that's just 2. and then simplify the square root of 18, which is 3 root 2, and subtract 1. So x equals plus or minus 3 root 2 over 2 minus 1. That's how you do that one. Moving right along. Hey, Miss A! Everybody say hi to Miss A! Okay. Write the equation of the line in slope-intercept form for the given information. So through those 2 points, the first thing I need to do is find the slope. So I'm going to go 3 minus 5 over 4 minus negative 4, which gives me negative 2 over 8, which is negative 1/4. Then I'm going to use the point slope form, and I'm going to use this one because they're both positive. I like positive numbers, just like you. Negative 1/4 times x minus 4. But I need it in slope-intercept, so I now have to solve this equation for y. I'm going to distribute my negative 1/4. That gives me a positive 1. Negative 1/4 times negative 4 gives me a positive 1. I'm going to add 3 to both sides, so negative 1/4 x plus 4. That's your answer. Okie dokie artichoke. The next one, perpendicular. So the first thing I have to do is solve this equation. Ooh, I think this was on your homework. For y. And when I do that, I subtract 3x and divide by negative 5. So let me show you that step because it's a little tricky. When I divide by negative 5, this becomes a positive 3/5. So the slope of my original line is 3/5, which means the slope of my perpendicular line needs to be negative 5/3. So the equation of the line is y minus 1 equals negative 5/3 times x minus 6. But I have to solve for y because it wants it in slope-intercept. Y minus 1 equals negative 5/3 x plus 10. Add 1 to both sides. And there you go. For the next one, through the point negative 2, 4 parallel to this line, so I have to solve this equation for y, and I get negative 1/2 x minus something. It doesn't even matter what this is. All we care about is the slope. So my new slope is negative 1/2, so I'm going to go y minus 4 equals negative 1/2 times x plus 2. Distribute my negative 1/2. I'm going to go up here. Y minus 4 equals negative 1/2 x minus 1. And add 4, so y equals negative 1/2 x plus 3. That's my answer. Alright. Finally, we're going to do this on the calculator. So we're going to go in, first we're going to say, use these 2 points to calculate the slope. So I'm going to go 170.1 minus 131.3 over 4, because that's 2005 minus 2001. So 170.1 minus 131.3 divided by 4. 9.7. The linear equation would be y minus 131.3 equals 9.7 times x minus 2001. Superimpose onto the scatter plot and predict the US imports. So if I do this on the calculator, I'm going to go stat edit. In L1, I am going to use 0, 1, 2, 3, 4, 5, 6, 7. And in L2, I am going to enter 135 for year 0, 131.3 for year 1, 134.6 for year 2, 138.1 for year 3. Oh, I can't read that one. I need to erase. 155.9 for year 4, 170.1 for year 5, 198.2 for year 6, and 210.7 for year 7. And then I'm going to go stat, calc, linreg, bars, y-bars, enter, enter, enter. And when I look at my graph, I still have my graph from the other problem in there, so I need to change that. I have to clear my Y2, and I have to put my plot on, and I have to change my window to go from, did I use 2000? No, I used 0 to 10 for X, and then my Y min is going to be about 125, and I'm going to go to 250. There's my line of best fit. Now when I look at my line, the actual line only goes through 1 point, but it has about 3 below and about 2 above, so it's kind of like the average of all the points. To predict Mexico, I'm going to go second trace to get calc, enter the value, and I'm going to put in 10 for y equals 2010, for x equals 2010. And the predicted exports are 235.74. That's from the calculator. If I had used my equation, it would have been different, but that's all there is to that.